All right, in this video we're going to talk about dividing radicals, or what we call rationalizing the denominator. This applies using multiplication of radicals, so make sure you've gone through the multiplication video first. When we're dividing radicals, remember division is represented with this fraction bar. And basically all we're saying is how do we kind of simplify it. We talked a little bit about simplifying if there's a fraction in the radical. The idea here is that we don't want to leave any radicals in the denominator. This is more like mathematical etiquette than necessary. And in order to simplify and create no radicals in the denominator, we're going to use what we call the conjugate. So I'm going to walk through these steps really quick. Step 1, simplify radicals in the numerator and denominator. If you can simplify them, go ahead and do so. Okay, now coefficients can simplify together, so like the 4 and the 3, if those could simplify, you could start there. The 5 and the 3, you could start there. And actually radical pieces can simplify together. So just like you can split up the fraction that we did, like a over b was the same thing as square root of a over the square root of b. If they're both underneath radicals, then these two pieces, right, they can simplify together. So I'm going to talk kind of about that. If there's still a square root that's a monomial in the denominator, you're going to multiply the numerator and denominator by that square root seen. I'll show you why. If there's a binomial, then you're going to need to use a conjugate. Now, let me show you really quick what we're talking about with a conjugate. A conjugate, I don't know if you guys remember, but when we did something like x plus 4 and we multiplied it by x minus 4, when we FOILed that, we got x squared, we got a negative 4 and a positive 4, which canceled out in the middle there. And then we had a negative 16 on the end. It created kind of a difference of squares. And when you do that with radicals, it actually will get rid of your radicals. So for example, if I had 2 plus the square root of 3, its conjugate, and I'm going to multiply it so you can see this, would be 2 minus the square root of 3. So we just negate that binomial, but create the same term. And if I were to FOIL this, notice what happens. I get 4. 2 times the negative square root of 3 is negative 2 square root 3. Square root of 3 times 2 is positive 2 square root of 3. And then I have square root of 3 times negative square root of 3, which is negative square root of 9. So notice that my middle terms, I have a negative 2 root 3 plus 2 root 3. Those will cancel when we use the conjugate, which is perfect. And then you have that 4 out front, and notice that the square root of 9 is just 3. So you really have 4 minus 3, which simplifies all the way to a 1. So the conjugate allows us to take a radical term and turn it into an integer value. Okay, and then if you can, you just simplify everything as much as possible. So let's look at a couple of these. The goal, again, is to get no radicals left in the denominator, and everything else is as simplified as possible. So on this first one, again, we're looking at this piece, and we're saying, okay, well, we could simplify, I guess, the 2 and the 64, but I notice already that the square root of 64 is 8, right? So on the top I have 4 square root of 2. This is really 3 times 8, or if you want me to build the little tree here, I could have a group of 8s there, right? So we multiply that out. That's going to be 24 on the bottom, and you've got 4 square root of 2 on the top. You just treat this like a little fraction that you're going to simplify. Again, the 2 is in the radical, so he can't simplify with other parts. And with the 24, you can't go like 24 and simplify with the 2 because he's inside of a radical. But we can simplify the coefficients here, 4 and 24. So if 4 comes out of both of those, it goes into that once, goes into that 6 times. So this is really like 1 square root of 2 over 6. Okay, and we would finish right there. Now, again, I talked about you can take these radical pieces, and if they simplify, you can treat it like a fraction. So really, this would be like the square root of 1, and this would be, because it's dividing by 2, 2 goes into both of these, and then 5. So this is kind of like 5 times the square root of 1, which the square root of 1 is just 1, so we don't even need to write that guy, over 3 times I wrote that bad, sorry. 3 square root of 5. So notice we just treated this like a fraction. 2/10 became 1/5, and the square root of 1 simplified. So this is one of those situations where you have a monomial in the bottom. So it says multiply the numerator and denominator by the square root of the denominator that you see. So for example, this has a square root of 5 stuck in the bottom. I'm going to multiply it by the square root of 5, and whatever we do in a fraction to the bottom, we also have to do to the top. So notice here we end up with 5 times the square root of 5 on top. On the bottom, we have this 3, and when I multiply square root of 5 times square root of 5, I get square root of 25. Now remember, the square root of 5 is just 5. So essentially I have 5 square root of 5 on top. Ooh, it's looking crazy. And then on the bottom, I'm pulling out that 5, multiplies by the 3, and I just have 15. Now, again, if you can keep going, notice 5 and 15 can both be divided by 5. So that would be a 1, and this would become a 3. So that would be like 1 square root of 5 over 3. Okay. Again, if you look at number 9, I'm going to jump down to this one before I talk about the conjugate. On number 9, you'll notice that like the 3 and the 6, those could simplify again right there. I'm going to show you that if you didn't notice that, that's not a big deal. Sometimes as soon as I see a radical in the bottom, I'm like, oh, I need to rationalize it. So if I multiply him by himself, he'll go away or simplify. And whatever we do to the bottom, we also do to the top. So if I multiply this over here, right, the 2 times the coefficient is 2. The radicands, 3 times 6 is 18. And then on the bottom, the square root of 6 times the square root of 6 is the square root of 36. So on the bottom, I'm just going to have a 6. There's a group of 6s. Square root of 36 is 6. And on the top, I now have 2 square root of 18. I do need to go ahead and break down that 18. So I would have 2 and 9, 3 and 3. It looks like we've got a group of 3s there. So the 3 comes out and multiplies by the 2, and we end up with 6. Square root of that 2 that's left over goes back inside over 6. Again, 6 over 6, that's going to simplify, right, and just have the square root of 2. Now again, if you wanted to simplify the 3 and the 6 and the radical first, you could have done that. 3/6, you treat it like a fraction. That would be like 1 over 2. So that would be like 2 square root of 1 over square root of 2. It became 1/2. The square root of 1 is just 1, so it's like that one doesn't need to be there. And then you're just rationalizing again, but this time the square root of 2 is there. So notice when I multiply top and bottom by square root of 2, the top I get 2 times square root of 2 over the square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2. So those 2's would cancel and I would end up in the same place. Okay, lastly, let's talk about the conjugate. If there's a binomial in the bottom, like this example right here, we've got 1 plus the square root of 6. This is where we use the conjugate. And again, you multiply this binomial by its conjugate, so that means we just negate the middle term there. If you multiply the bottom by a value, you also have to multiply the top by the same thing. So top and bottom by the conjugate. And notice it's a binomial, so when I multiply this 2 over, it needs to multiply by both terms. Okay, 2 times 1, so my numerator is going to be 2. 2 times negative root 6 is just negative 2 square root 6. So that's my numerator. On the bottom, I need to FOIL. So I've got 1 times 1 is 1. 1 times negative root 6 is negative square root of 6. Square root 6 times 1, just square root 6. And square root of 6 times negative square root of 6 is negative square root of 36. We multiply those radicands. Then I simplify. So again, these middle terms are going to cancel out. That's why we choose the conjugate. And this square root of 36, right, is just 6. So on the bottom here, we have 1 in the front minus that 6 at the end. So really on the bottom, we have a negative 5. So we're going to have 2 minus 2 square root of 6 over negative 5. Sometimes we'll play with that negative and get the negative out of the bottom, but it's fine for now. I just want you to practice that. Now, the last thing is the only thing we could simplify at this point. You can't simplify just two of the pieces. This one, unlike the last one where I had one piece over one piece, I now have two pieces on the top. So if I want to simplify with the denominator, it has to also divide out of both of the top coefficients. So the only time I can divide out of it if it comes out of all three pieces. Okay, let's try another one, and maybe there's one with an example like that. So let's look at number 10. Again, we've got a binomial on the bottom, so I know that I need to use its conjugate. And if I multiply the top, I also multiply the bottom by that same thing. Again, conjugate is the same binomial, different operation sign. Again, on the top, I have a binomial that needs to be multiplied, so I start with these first two terms. The 2 times the 4 is 8. Then you have a square root of 3. Then we multiply these two terms, so 2 times that 1 there is 2. 3 times 5 on the inside of our radicals gives us 15. That's the top. Then on the bottom we FOIL. 4 times 4 is 16. 4 times the square root of 5 is just 4 square root of 5. Negative square root of 5 times 4 is negative 4 square root of 5. And negative square root of 5 times square root of 5 is negative square root of 25. Okay. So those cancel out there in the middle. On the top it looks, let me finish the bottom. So this one is 5 and 5, right? Square root of 25 is 5. So you've got 16 here in the front, and then you've got the minus 5 at the end. So on the bottom, it looks like we're going to have 11. Oh, this won't simplify anymore either. Okay, so on the top, for my final answer, I'm going to have 8 square root of 3 plus 2 square root of 15 all over 11. Now again, I could simplify only if 8 divided by the same number that 2 did and 11. So all three of those need to have a common divisor before I can simplify anything out of there.